Are you scared yet?
Did you have bad time?
So we're doing module 14, review question number 5. Please read the question, Martin.
The order of a chemical reaction with respect to one of its reactants is 0. If you double the concentration of that reaction, what happens to the rate?
So this is asking you if you understand what we've been doing in this module, okay? So if the order is 0, what does that mean? That means when we have this substance concentration, what is our exponent?
0.
0. So anything to the 0 power equals what?
1.
1. So if I multiply this by 2, it's still 1. If I multiply this by a billion, it's still 1. It doesn't matter what I do to the concentration, whether I double it, halve it, whatever, because with respect to the reaction, it has to the rate of the reaction. I mean, obviously if I take it away, if the concentration, if there's nothing of this substance, there's not going to be any reaction. There's going to be a 0 rate because there's no substance. But with respect to the rate of the reaction, it doesn't matter if I double the concentration because it will always be 1. So that's how it affects the rate. Because remember, the equation is R equals K times the concentration of A to some power X times the concentration of B to some power Y. And if X is equal to 0, then this is just 1, and it doesn't matter the concentration.
Yeah.
It's math, people. All right, number 6, please.
A student is studying a chemistry book and reads that for the following reaction, CH3Cl plus...
Sorry, CH, sorry, I think I said CH. CH3Cl
plus NaF yields 3CH3F.
Sorry, 3CH3F.
No, 3CH3F.
Not 3 of them. CH3F.
Dang hiccups.
Plus
Plus NaCl.
Okay.
And the rate equation is R equals K
concentration
times concentration of CH3Cl times concentration NaF. The student looks at the rate equation and says that since temperature does not appear in the equation, the rate of this reaction is obviously not affected by temperature. Is the student correct, and why or not? Why not?
Okay. So the student is not correct, okay, because the rate that we're looking at here is not some independent value, right? The rate is based on experimental actual recording. So if you do the temperature, if you do the experiment at different temperatures, you'll actually end up with a different R, okay? So this experiment is done at a particular temperature. I don't know what it is because they don't tell us in the question. So although temperature does not appear in the rate equation, the student is correct. The rate is found by doing the experiment at a particular temperature. So if the experiment had been done at a higher temperature, it would have had a different rate. That makes sense, yes?
Yes.
Okay. So now we're looking at number 7.
What do we call a chemical that increases the rate of a chemical reaction without getting used up in the process?
Okay. So what do we call that?
A shortcut. A flux. No. It's right in my head, but
Don't have catalyst.
Yeah, that's it. The catalyst.
Catalyst, yes. So a substance that increases the rate of a reaction without getting used up is called a catalyst. And this is on page 481, I believe. Catalysts speed up reaction rates by lowering the activation energy of the reaction. Yeah, they are shortcuts. Exactly. Okay. And now we'll do number 8.
A chemist studies 2 different reactions and finds that the activation energy for reaction 1 is significantly higher than that of reaction 2. Assuming that the reaction concentrations are roughly the same in the reactions, which reaction is the fastest?
Okay, so the activation energy of number 1 is greater than the activation of number 2, and they have the same concentrations. That's what we're told. And the question is what again? Sorry.
Which one?
Which one is the fastest?
The
Well,
second
it should be
one.
the faster. Okay. So the higher the activation
there
energy.
There doesn't need to be 3 or more for there to be a superlative.
This is what we talked about in the last module, right? We've got like this, and we've got the activation energy. Okay. So the higher this is, the harder it is to run the reaction, right?
Yeah.
So that tells us that the one with the higher activation energy will have a lower reaction rate. One with the lower activation energy will have a higher activation, will have a higher reaction rate.
Yes.
Okay, now we're going to do 9 and 10. Let's power through this video, baby.
What is the main difference between a heterogeneous catalyst and a homogeneous catalyst?
Heterogeneous.
Yeah.
Homogeneous. Okay, so these are defined on page 481. Okay. Oh, I spelled it wrong. It is genius. Okay. So heterogeneous tells us that things are different, right?
Yeah.
And homogeneous tells us that things are the same. What is the different and the same thing that we're talking about with these things?
Heterogeneous catalysts are in a different phase from any of the reactants in the reaction.
Right. So these are in a different. What do we mean by phase?
In that time between 13 and about 21.
Are we talking about states of matter?
Yes.
Yeah, so when we're talking about phase, we're talking about what state of matter it's in. So that's one of the reasons why in the chemical reaction equation, you're going to be including the phase, gas or liquid or aqueous, which of course is solid. All right.
10. Dang it. What is the purpose of a catalytic converter in an automobile?
So this is described on pages 482 to 483, right? It gives the equation 2CO gas plus O2 gas yields 2CO2 gas. So the catalytic converter is a heterogeneous catalyst that converts carbon monoxide in your exhaust to carbon dioxide. What is the purpose of this?
Well, carbon dioxide could kill you, but carbon
dioxide can't kill you. You breathe, you make carbon dioxide.
I mean, like,
if you run out of oxygen and you're in a room with only carbon dioxide, you'll die because you'll suffocate, not because carbon dioxide killed you.
Anyway,
carbon dioxide. Excuse me. Time out. I don't care about your carbon footprint. That's a bunch of hooey. Okay. Carbon dioxide is the greenhouse gas that they're talking about.
Anyway,
we're making a video. I'm not interested in listening to your opinion at this time.
Carbon monoxide is poisonous.
Yes, carbon dioxide is not a poison. Carbon dioxide is called a greenhouse gas because in controlled experimental conditions, carbon dioxide presence will make a container warmer than a container with less carbon dioxide. However, okay, carbon dioxide is not a poison. It will not kill you. Carbon monoxide is a poison, will kill you. So it's to reduce pollutants in the atmosphere. Okay, carbon dioxide is a harmless gas. In point of fact, carbon dioxide is a necessary component of life for plants. So without carbon dioxide, we have no green growth. Okay. So increasing rates of carbon dioxide in the atmosphere allowed plants to grow on the earth.
Yeah.
So without which nothing. Any questions about this? So yeah, it's a heterogeneous solid catalyst that causes this reaction to occur. And it's not used up, so it stays in your car and continues doing its function. Yay.